Valency bond theory. Hitler and London gave a theoretical treatment to explain the formation of covalent bond in hydrogen molecule on the basis of wave mechanics of electronics. It was further developed by Pauling and Slater. The wave mechanical treatment of VB theory is beyond the scope of this textbook. A simple qualitative treatment of VB theory for the formation of hydrogen molecule is discussed below. Consider a situation wherein two hydrogen atoms HA and HB, so this is HA and this is HB, are separated by infinite distance. Initially, the distance between these two hydrogen atoms is infinity. The distance between them is infinity. At this stage, there is no interaction between these two atoms and the potential energy of this system is arbitrarily taken as 0. So, potential energy is 0. As these two atoms approach each other, so now initially it is at infinity, now it is slowly approaching. In addition to the electrostatic attractive force between the nucleus and its own electron, purple arrows, the following new forces begins to operate. So we can see that green arrows and brown arrows. The new attractive forces, green arrows, arise between nucleus of HA, so this is nucleus of HA, and valency electron of HB. This, because this is positive and this is negative, there is a attractive force. Nucleus of HB, this one, this is positive, and the valency electron of HA, this is negative. So you can see the attractive force between the two hydrogen atoms. The new repulsive forces, red arrows, arise between the nucleus of HA and HB. HA nucleus is positive, HB nucleus is also positive. So both are same polarity. It experiences repulsive forces. Valency electrons of HA and HB. Valence electron of HA is negative. Valence electron of HB is also negative. So it experiences a repulsive force. The attractive forces tends to bring HA and HB together, whereas the repulsive forces tends to push them apart. At the initial stage, as the two hydrogen atoms approach each other, the attractive forces are stronger than the repulsive forces, and the potential energy decreases. A stage is reached where the net attractive forces are exactly balanced by repulsive forces, and the potential energy of the system acquires a minimum energy. Figure 10.7b, VB theory for the formation of hydrogen molecule. X-axis internuclear distance in picometer, and in y-axis potential energy kilojoule per mole. Here it starts from stage 1, stage 2, stage 3 and stage 4. At this stage there is maximum overlap between the atomic orbitals of HA and HB, and the atoms HA and HB are now said to be bonded together by a covalent bond. The internuclear distance at this stage gives the hydrogen-hydrogen bond length and is equal to 74 picometers. So here the potential energy is minimum, which is minus 432 kilojoules per mole. At that point, the internuclear distance is 74. The liberated energy is 436 kilojoule per mole, and is known as bond energy. Since the energy is released during the bond formation, the resultant molecule is more stable. If the distance between the two atoms is decreased further, the repulsive force dominates the attractive forces and the potential energy of the system sharply increases. Now if you look into the graphical representation, here we have internuclear distance. So this side is increasing 7400 picometer 200 like this. So at stage 1, potential energy in kilojoule per mole, say it's 0. But when the internuclear distance decreases, slowly it is decreasing. At one point, there is an attractive force, that is stage 2. And there is one point, the attractive forces and the repulsive forces are equal. And at that point, we have the internuclear distance as 74 and the potential energy as minus 432 kilojoules per mole. But still, if you decrease the internuclear distance, then you will experience a repulsive force. So as it goes approaches 0, the internuclear distance, when it approaches 0, the potential energy shoots up to very high value, with the unit being kilojoules per mole. So at this point, the repulsive force and the attractive forces are equal, and the hydrogen A and B, hydrogen B becomes stable, and that distance is 74 picometer. And at that point, the potential energy is minus 432 kilojoules per mole. So this is the basics of VB theory. Hope you have understood this topic. Thanks for watching this video. Nandri.